relevant it will be, the more relevant things will be to kind of what you want to hear about and what you know and what you don't know. So I was just wondering if possible to kick things off, if you can just drop into the chat if you're currently using a CI or a CD system, just to tell me what you're using so I know what people are familiar with. So you could be using things like Jenkins or Bitbucket or GitLab, or there's loads and loads and loads. It's okay if you haven't used any, that's still good. This talk is not heavy too technical, it's more a kind of overview of the landscape of the ecosystem. I'll just give it another 5 seconds to see if anyone else wants to drop into the chat. Okay, it's coming through now. Nice. So we've got AWS coming in there as well, which is quite a good solution. Azure, I've just launched something called Azure DevOps, which is kind of similar to AWS pipelines. See, it's supposedly quite popular. Okay, but I've got some kind of idea anyway. This is the talk called The Future of Continuous Delivery. My name's Paul. I am an open source contributor. I'm a member of the Jenkins project, and I'm a member of the PHP project and the web team, and I'm a PHP Fig member of the PHP community, and I create PHP standards. We call them PSRs in the PHP world. I organize conferences, and I'm a member of the CD Foundation, which is part of the Linux Foundation, the OS in the foundation. And I work as an independent, have worked as an independent consultant as a CTO, head of engineering, as well as being full-on principal level architect, engineer, QA, DevOps person, all in. And I spend a significant amount of my time rolling out CI/CD solutions for companies all over the world and embedding continuous delivery processes and solutions into companies in the private and public sector. The agenda for the talk is in 3 sections. We've kind of got a little bit of a quick journey just to help people realize where we are at today and kind of how we got here. So that's the preamble. And then we've got new innovations that we have now that have already had an innovation that's happened 4 or 5 years ago. So that takes us to like today, and then also where the innovations are taking us in the industry and what they expect in the coming months and years ahead, which you'll see obviously being part of tech, and yeah, kind of forward stuff. So if anyone's got any questions, Herb, no, I don't want comments on every typo, but maybe at the end, otherwise it'll drive me nuts. I've got slide numbers at the bottom of most of the slides, at least. So if you've got a question, you can say like slide something and you can drop it. So as things pop into your mind, you don't have to wait until the end to ask questions. You can just write the slide number and just drop it in the chat, and we can get to it either halfway through or in real time or at the end as well. So there's that. So I guess this is traditional CI/CD, right? So we have a monolithic architecture. So since the 70s, I suppose, that when we've been doing what we now call CI/CD, we had one application and it was a monolith. So it was a pretty predictable the way things are laid out, and as such, our CI/CD pipelines look like this, which is just a pipeline hooked up to one repo and for one app, one monolithic app, and that was it, right? So traditionally, this is what our kind of pipeline stages look like. So you've got build, and then test and CI, and then you've got deploy, and then you've got production. So life was simple, predictable, and stable up until 2012, 2013, I suppose. And then ultimately what changed? So the point is that globally software organizations and internet companies are delivering more and more software at a rate and scale that we've never faced before as an industry. So like the launch of smartphones, right, and having web access and the demand that these apps put upon us on the cloud, on the internet, for the size and the scale of and the rate of change of all our projects, that put quite a lot of unprecedented demand upon new challenges on us all. But specifically, it has been hurting our organizations when it comes to creating continuous delivery solutions, because ultimately the solutions we had for continuous delivery in the past, which was we have one thing and we're going to deploy that one thing on the cloud, to what changed how that's different had to change, then that made it really difficult, and obviously that'll make sense why throughout the talk. So we went from a monolithic architecture to what we call microservice or distributed systems architecture, where we didn't just have one pipeline for one thing, but we had multiple things. And then the questions arose, such as, do we have multiple repos for each thing? Do we have multiple pipelines for everything? How do we know about dependencies between the things? What about ordering? There's a lot of open questions, because the Jenkins was the world's, still is, but especially at the time, the world's largest CI/CD piece of software. And so the tool itself, Jenkins, and all the pipelines and all that, they were built with the monolithic architecture in mind. So sequential running of a pipeline, step 1, 2, 3, 4, 5, and then you're done. Whereas these days you've got multiple things potentially kicking off simultaneously or whatnot. So the challenge is what happened when, as an industry, we shifted from monolith to distributed systems, is the pipeline development became really complex, and like sharing code steps between pipelines became complex as well. And ultimately it became the wild west when it came to building these solutions, because there were no right or wrong, there were no industry standards, there was nothing really to look at or to guide us on how to take existing tooling, which wasn't really designed for that, and try to make it work as good as we could. So what happened was, this is where the trigger of innovation occurred. So up until this point in the talk, it's kind of the past, and then now that triggered an innovation, and the private companies led the way in terms of documenting on the internet how they are doing their CI/CD stuff at scale, using like 5, 10, 100, 200 microservices, right? And how they're doing it. And so everybody kind of a lot of people who are looking for a place to learn from, and how to structure or restructure when converting apps from monolithic to microservices type models, then how did we they needed somewhere to look at. And so companies like Weaveworks and Codefish led the way, and others followed. However, that was just what worked for them in their organizations, and it wasn't really a reflection of how your organization worked. Remember, CI/CD processes, automation processes, they're a reflection of your organization, ideally. So the way your stuff is set up isn't necessarily going to work for another company, because they have different processes or different quality gates, different stakeholders, different gatekeepers in effect to that. So what happened is, then private sector companies started creating closed source and proprietary general purpose solutions, like you see Circle CI and Bitbucket and GitLab, things like that. And so these companies led the way in terms of, they had money, they had funding, and they were able to take sort of existing open source technology, which is free, and then use the money to innovate and adapt and create their own proprietary platforms that do allow, to a certain extent currently, to use these solutions to try to get some stuff going. Having said that, it doesn't offer you anywhere near the control or the nitty-gritty details on how to structure your CI and CD processes to reflect and to your way your organization works. And so they are quite primitive, they're opinionated setups, and they're general purpose, so that you need to structure your organization's processes and your release processes around what these tools allow you to do, right? Ultimately, that's the trade-off you're making when you invest in either open source tech, you can build it all yourself, or pre-built general purpose solutions. Now, and so that's kind of where they fit in the industry, but they have led the way until around 4 or 5 years ago. Then the open source community, sort of the dust settled. We looked at how these private sector companies were doing stuff, and how the community were using these new companies to try to make things happen. And so that allowed the team at Jenkins and the team at all the other technology to sit back, reflect, and go, okay, cool. Now we see how things have done. Private companies have tried it. It's now time to then innovate on open source, on what once was fit for purpose, say Jenkins and other things that were very monolithic minded. Now we have a new wave of innovation that's now, as of 4 or 5 years ago, caught up and started getting more popular to the point where now we're readily replacing old systems or these kind of cloud hosted proprietary solutions with your own stuff, right? But it's easy these days, and that's the whole point. So there's a few innovations that you'll see in this talk that you may or may not have heard of. Now, you'll know more about these tools in the next few slides, but these are examples of the innovations that we have in this the CI/CD space. 1 second, I'm going to turn off. I'm getting a beep, notification beep from Discord. Done. These are a few of the innovations that we have at the moment. So there's things like on the top left, that in previous slides, there's Tecton, there's Flux, there's Argo, there's Captain, there's also Jenkins X, which is something that I help work on, and that's like the new Jenkins basically, but it's microservice based, it's cloud native, and all that. Spinnaker being also one more popular option. And then there's this new innovation that's came out called GitOps, right? Which is how we do version management of our different services that we launch in the cloud, but in a more meaningful and easy to manage way. Again, so GitOps is a thing that's came out of innovation. It's a way of working that's came out of using these proprietary companies to try to kind of get things moving. There's also the CD Foundation, so this which is organization I'm part of. So these were the founding projects of the CD Foundation. These four were kind of day one. The founding projects. This on the top, you've got the Linux Foundation, which is the OS and the kind of the community. For example, the Apache Software Foundation is part of the Linux Foundation, I believe. So they're like, it's a sub. You got the main Linux Foundation, and you got child foundations. So the CNCF on the right hand side, the Cloud Native Compute Foundation, that's where things like Docker and Kubernetes live, right? Maybe not Docker, I'm not sure of their status, but Kubernetes is one of the flagship projects of the CNCF, and also Captain has joined, which you'll know more about Captain later in the talk, and there's many other notable open source projects that have joined the CNCF. Now, the word cloud native doesn't mean Kubernetes. The word cloud native means it's containerized, and there is code there that you can launch it into any Kubernetes cluster, but it is not restricted to any particular cloud. So Kubernetes runs on any cloud, whether it's your own local hardware, like on-premises hardware, or it's AWS, Azure, Google Clouds, etc., right? So the term cloud native just means it's kind of Kubernetes based. It's containers that run in Kubernetes, and that's abstracted from the cloud. So therefore, you build a solution once, and you can take it between clouds, right? And that's the kind of creme de la creme of building software that can be hosted on a cloud on the internet. And so as a sister foundation to that, which is launched 2 years ago, is the CD Foundation. And that's specifically all the cloud native stuff that's happening and all the other open source stuff that's happening in the world, but it focuses on the innovation of CD specifically as a subject matter within the whole innovation that's happening in the world in the recent years. And examples of that are, like, say, Jenkins X being part of the CD Foundation. And others, and there's some more recent projects I've joined CD Foundation, which is things like Screwdriver and stuff, which you can check out on the internet. But this talk is more of an overview, things for you to at least have heard of and get exposure to, and potentially research on your own as well. So these are just tools that make things easier. So we innovated but things became really hard and kind of very bare bones, and that's what happened 2014-15. This, in my opinion, from my perspective, Tecton was the first thing that triggered the innovation, the outcome of the trigger of innovation to the open source side, when open source started to catch up. And what Tecton project was basically a cloud native platform agnostic way to create pipelines and tasks and schedule tasks and stuff, but it was all fully container based, and it all ran on the cloud, and it can run on any Kubernetes cluster. So you can, and it's just YAML files basically that configure your stuff. So you could just take that and apply it on any machine, any cluster, and your pipeline system there is no Jenkins, it would literally just pipelines would run. But it was very bare bones, very, very hard to configure, not very user friendly or developer friendly, but it worked. And so when this started to get pretty popular, people are saying, well, actually, we can now again restructure and rethink how we do things, and it is now feasible to do things stable and fast and really well thought about on a cloud native landscape. Other things that are happening inside the CD Foundation are what we call SIGs. So this was taken from the CNCF group, because the SIGs stands for special interest group. So in Kubernetes, there's like the people that specialize in security or networking or other special subjects. So within the CDF, we've got the interoperability SIG. What that means is basically the ability for two CI or CD projects being able to build something once and drop it into any CI/CD system and it will work, right? And so there's like, you'll see in later slides all the different CD systems we've got and CI systems. So imagine being able to build something once, and then you can just drop it in to any future. If you move between projects, between companies, between whatever, you can just drop it in. And so that's the objective of the interoperability group on the SIG. There's also a new thing happening currently, which is called the events SIG, and this is around having an event that gets triggered on one system that can then speak to another CI or CD system to do something, basically. So you don't need to build everything in the one place, or if you've got most of your stuff and pipelines in one area, but then you've got new stuff in a new area, then you can just trigger events, and then these other systems sort of know how to understand what each other's events are and stuff. So it's like a standardization of events. If that didn't make sense, don't worry, because this is stuff that's kind of on the leading edge, but I wanted to kind of give some highlight to what the CDF are and what we do, basically. The next innovation that's occurred is something called GitOps, which I was talking about. And basically this GitOps, to try to summarize it, because we went to microservice architecture, but let's say we have 10 different services running in the cloud, you don't know easily which versions of which services are running on if you've got 10 projects, which out of those 10 projects, what exact version number and deploy label is against each of these 10 things. You don't know, right? And so it's very hard to tell a system, hey system, I want you to deploy version 1 of these 8 systems, eight services, but then these other 2 need to be these versions, right? It's quite hard to have a standardized way out of the box to do that. So everyone had to kind of roll their own solutions. Like I said before, it was the wild west. And so something that's came out of the software development and infrastructure communities is something called GitOps, where you can have a file that CI and CD systems understand how to read, and in that file you can just declare right in a text file in a Git repo the services that you have in your platform and the versions of services that you have, and but most importantly, against which target environment. So you may have a featured environment and then a QA environment, and then you may have staging and then pre-production and then production environments. So as changes make their way through different target states, different versions, different changes, and that's called promotion, and your artifact, the new version of your app, gets promoted up through the chain up to its path to live, all the way through to production. So managing which environments contain which services and which states of those services, by state I mean versions, it's very hard to manage. So GitOps allows a way to basically make that easy. Here's an example of GitOps. So standard stuff where a developer pushes changes to a repo, and that triggers, say, a Docker build, and that and does maybe some CI stuff, right? And then if it passes everything, then it packages up the repository or the Docker image. So from V1 to now V2 of your app, then that's sitting in the cloud. That's a Docker image. That's an artifact that's passed some kind of automation testing, and it's ready to be deployed onto a cloud environment for further manual and or automated testing. So this is where GitOps kicks in. So either a developer or someone on the ops team there's a second Git repo now. So there's not just one app repo, there's a deploy repo. And then this deploy repo we could have things like branches. So it could have the QA branch, staging branch, pre-production and production branches, right? So if you think about it, you can just make pull requests between the branches to promote changes up through that. But most importantly, when someone in your team changes this file and pushes to a PR or to a branch, the most important thing is these new CD systems that were built, they actually listening to this repo and they automatically react to changes. So, and they know that the differences are. So you no longer need to say, when you have these tools set up, you no longer need to say which environment I want to deploy new changes onto, because they're actually already listening and waiting for you just to tell them in a very simplistic manner what is changed or what you're rolling back, for example, and they'll just go and do it. And this is just FluxCD is an example of a CD tool, and that just literally takes your stuff and updates the system. Right? I hope that made sense. If anybody's got any questions on GitOps and stuff, you can drop it in the chat. I'll try to explain better. Here's another way whereby they're using Amazon for hosting the Docker images, and in the CI pipeline, it updates the GitOps repo basically with like a new version of the app, and there for the webhook sync, the Argo, again, Argo CD being another CD tool that I'll talk to you about. That's, again, it's a webhook, it's listening and it's waiting, or it's polling for the changes. And then once it understands that you've made a desired change onto the desired environment, then bam, it kicks in and it does a deploy for you. And you've already kind of set up how that deploy happens. So it's kind of all nice and it flows. So GitOps, as a summarization, it was so popular. Why? You're defining the desired state declaratively, storing in Git and having a process that's continually synchronizing things into the desired target locations, which is KAS, stands for Kubernetes, right? Yeah, to be honest. So that's my point is Argo and Flux are the main players in the GitOps world at the moment. And they kind of come with GitOps out of the box, and that's the way they recommend it done from day one. So if you're modernizing your CI and or CD pipelines, or you're starting a brand new project, then you want to start with Argo or Flux, basically, and that puts your project in a really strong foothold for the future. Anyway, so here's one of the innovations. So Jenkins became Jenkins X. It's an out of the box solution. It's cloud native, so you can deploy Jenkins X itself onto any cluster, and it also creates clusters for you automatically. If you don't have one, you just tell it, give it your credentials for like AWS, and off it goes. It installs itself. So it's basically what Jenkins would always have liked Jenkins to be like, in terms of, it has maintenance challenges. So now, so Lee's got a question about Argo and Flux. So hi Lee, the main difference is Argo is more mature and it's got more features and it's more heavily adopted. Flux is still on the leading edge, and it's more of a lightweight solution, simpler solution. It's got less features, a bit more lightweight, a bit more simple because it offers less features. So it's a lot simpler to reason with. So if you've got quite straightforward kind of CI and deployment type strategies and processes on your environments, then Flux might be a way to go. But Argo is obviously a safe bet, and it's scales if you've got quite complex or will have much more complex deployment strategies going forward. Then that's my opinion on how to differentiate between Argo and Flux. Back to Jenkins X slide. So to give you an example, so out of the box, Jenkins X is actually an opinionated solution. This is highly configurable, and it gives you environments on the cloud for local staging and production, for example, and then it'll allow you to easily promote your services up and down the chain between environments, staging, pre-prod, prod automatically for you. And it really just attaches onto existing stuff, which makes it really nice. Or it can be its own dedicated sort of cluster, Kubernetes cluster if you don't have one, and it can do all your stuff for you there. But it basically does so much for you. You just sit back and watch it work, and it makes you look like a genius. But actually, it's not. You're just configuring Jenkins X what to do, how your organization works, what your environments look like. Do you need manual sign off? Can you get automatic sign off if things pass on master branches? All that kind of good stuff. And it's GitOps powered. But so the point is, go and check out Jenkins X, check out maybe some YouTube videos, recent YouTube videos, and some documentation if you're interested on that. But it will do a lot for you, and that's the added value why Jenkins X, comparing Jenkins X to say Argo or Flux or others, it's kind of out of the box, and it's all kind of ready to rock for you, in effect. The next project I'm going to talk about is Argo. So the Argo project is utilizing GitOps from day one, and as well as other modern best practices. So remember I said to you, it was the Wild West. We didn't really have good practices or good best practices on how to handle all this stuff as it gets more complex in a cloud distributed world. Well, Argo and others basically give you the approaches straight out the box. So it's kind of, they're just showing you how to do stuff rather than you having to figure it all yourself. Argo are at the heart of innovation, and they are the unopinionated solution. So you kind of build your own things out as compared to say Jenkins X, which is like by default heavily opinion. You could compare this to the PHP world between say Symfony and Laravel, whereby Laravel is an opinionated system that gives you like everything out of the box, and then you just have to start like turning things off that you don't need and kind of ripping things out that you don't want. But it's a kind of big kind of skeleton app thing with all the bells and whistles. Whereas Symfony PHP framework is more, you start from a bit of a clean slate, and then you only add what you need as and when you need it. So that's the differences between the project types as a PHP thing. There's also innovations happening not in the CD landscape specifically, but in the cloud native / Kubernetes landscape, which is developer focused. Because, like I said before, a lot of these Kubernetes tools, they can get Kubernetes itself is quite difficult to grasp. It's a learning curve, and it can get quite in depth to build things in. And so, any opportunity to make it easier for developers, then that's obviously the next level of innovation, which is abstractions and simple solutions and making things easy for the developer or like DevOps infrastructure communities. And so Kuvela is just an example of that, where you can check it out, whereby you don't have to write like loads and loads of Kubernetes files and like YAML files and all the stuff that says like I want a so like a service, a Kubernetes service, an ingress rule, which is like an incoming like domain name maps to these containers, and this domain name maps to these, like the user.company.com maps to the user container, and like payment.company.com maps to the payment container running, right? That's what a service, and that's what an ingress rule is in Kubernetes, for example. So there's all this stuff you have to configure, but kubevela is basically a nicer YAML syntax on top, and it's really just you write 20 lines of code instead of writing 200 lines of code. So that's kind of why especially for developers, you know, that are here in this like PHP Hampshire meetup, you could probably be quite an effective kind of DevOps person without needing to know too much if you consider using kubevela instead of going straight bare bones Kubernetes for your application level stuff. So that's why it gets a shout out. Next we have Captain. And this is where I've not mentioned Captain yet, because Captain kind of sits above Flux and Argo in terms of their tools. It's an umbrella around all the tooling needed for development. It also encompasses tooling around testing and observability tools. So observability tools are things like Datadog, New Relic, or your own hosted monitoring solutions like Grafana and Prometheus dashboards and Elk stack type dashboards. So you set up your own stuff, your own data, and you fire it in, you create your own dashboards. So those are all communicatable, and Captain understands them, so you can hook Captain up to them, and that's where it becomes next level intelligent as a CD tool. So what they call it is a control plane, which is kind of like a command center for all of your stuff that's going on in your environment promotion, all the way from like a QA feature branch thing all the way up to production, and each of the apps and services that you deploy. There's some terminology that I just wanted to cover, which is something from the SRE / DevOps world called SLOs, SLAs, and SLIs. So an SLI is a service level indicator, and that's just an indicator, a key measurement on how to determine the availability of a system, which is how fast it's responding, right? What are the milliseconds, and how, you know, what's the performance like of that service that's running. The SLOs are how much availability we expect to get out of a system. For example, how it should scale and what point should it stop. We should really expect it not to scale beyond, so therefore how much traffic can we send at it, or whatever, right? And an SLA is a service level agreement, which is like a legal agreement to see what happens if the system doesn't meet the SLOs of how available it is, I suppose, right? Anyway, that's just some terminology. Now, if we come back to Captain, it says SLO score here, and this is why I explained it. So this is the different environments. So this is the dev environment, and then the staging environment. Now you've got to promote things through this life cycle, right? Now, what Captain is doing is it's not just in charge of doing deployments of your apps, telling the cluster, hey, cluster, you know, you're not running Docker container v1 anymore, it's now 1.1. That's in addition to deploying stuff, which you can also use down the bottom here. You can hook into Helm, that's the next one's Argo, you've got Jenkins, Prometheus, and stuff like that. So it can hook into other tools and let them do the job. So for example, let's say you've got a Jenkins pipeline or a GitLab pipeline already that does a job. Well, you can just hook that up to Captain, and that is that small. You don't have to refactor that. It can just be a small part of a new sort of overarching process for your application and services of that. So this is an SLO score of 97%, right? Meaning that Captain is continuously reading the data from your monitoring tools to see how your app is performing live on a cloud. And And so here's an example of a Captain pipeline, what we call a workflow. You could create this workflow also in Argo and in Flux and Spinnaker and Captain, but Captain's a level above these other tools, and it hooks into monitoring. So that's why this is different. So for example, number one, a user pushes a new Docker container gets built by a CI system or by a user who pushes it up, and then number two is a notified change. Number three is kind of like GitOps kicking in, and then number four, don't worry about that. 4 and 5, that's just kind of like some CI tests and stuff, right? Number 6 is it will actually looks at the monitoring feedback, and then 7 will actually update the branch. No, this is the GitOps repo kicking in. So this is saying on the environment X, we're happy for it to get promoted or happy for this to change. And so Captain will automatically touch your GitOps repo for you. And then it will do 8 is blue-green deployments, which means it will have, there's different deployment strategies that you can have in the CD world. So you can just do a straight swap over. You can do blue-green deployments, which is it launches a new copy of the user service on the background, and then it starts sending like traffic to that gradually. And if it's healthy for 30 seconds or 2 minutes, then it passes its health checks, and then it swaps out completely the old service with the new one. There's so many different deployment strategies that you can just choose on these systems that suit your organization. So sometimes you want to do rolling updates. There's blue green, there's red green deploys. There's all different ones, right? That I recommend you look at on the web. My point is that after it's deployed, it's replaced the existing app on the cloud with the new one, which is the green hexagon here on number 8. Then it's live, and what Captain will do is it will actually monitor the feedback from your monitoring platform on the health check on how that service is performing, again at an external perspective as well as internal. So internally, it will monitor things like CPU and RAM to make sure you've not done anything crazy. But it will also talk to your monitoring system and see, have your API responses slowed down, or have your web requests slowed down, or are you getting 500 errors? And so it monitors that feedback on number 9. And then when you create a Captain workflow, which is just a YAML file or whatnot, you define the alerts and the thresholds to which something will or will not progress up to the next stage of promotion throughout the path to live, and also outlining what a rollback threshold should look like. So this system will automatically roll back to the previous version if the stuff starts falling on its ass, basically, right? And so you tell Captain what that looks like in terms of what the thresholds are, and it just knows what to do, and it goes and does it. And so you basically just sit back and you just create like a YAML file or files that kind of just articulate your organization's workflow, and Captain will do all the work, and it will integrate into tooling systems, into monitoring, and lastly into it can hook into other subsystems. So let's say the deployment on number 8 wasn't actually done by Captain. It was actually like your Jenkins pipeline or your GitLab pipeline actually are handling that already. So it can just send an API request out to them to do the job and then come back, right? So it's got all the integration points, and that's why I like to highlight that. So it's tightly integrated. It can calculate SLOs, which is how well it's performing and stuff like that. And it takes information into consideration to whether that deployment should be allowed to go to the next stage or not. So if for whatever reason there's thresholds or there's things that it doesn't like on the next environment up in the chain, it won't allow you to go there. Or if it doesn't meet, for example, you've got staging and production. If it go to staging and things don't get faster, or things slow down for some reason, or the CPU and RAM starts spiking or whatever, it will actually block that and fail that workflow. And it will not allow you to go to production, because it's looked at the monitoring data automatically and it told you, by the way, this messes up your system, and so that it will just be like red flag basically, and it won't allow you to go that to production. So they're called quality gates. Yeah, all right. So that's Captain. Hope that made sense. Hold on one sec. I just want to check the slide order. Okay, cool. Okay. Yeah, we're good. Just like to check. So that was a kind of overview of some tools, right? Now that's kind of where we got to date with all these tools. But what to expect kind of now and what in the future is ultimately GitOps is driving us forward as a community, has already done so, and I highly recommend that you check that out. There's we migrated from open source tools to the closed source proprietary tools in the cloud as a stopgap in effect, but they're like opinionated and closed source, and now we're moving into a future of where the CD tools are now taken back over again, and they're starting to make their way back into organizations. But continuous delivery being a focus here. Argo CD is driving us into the future with event-driven pipelines. So I haven't spoken about event-driven stuff, but I'll talk about that in a sec. And the innovation of Captain is becoming your control plane for all the integration of these tools. And the Jenkins X CLI is something I want to highlight, which is up and coming and may already be stable. I'm not sure, worth checking out. So the Jenkins X CLI is not actually Jenkins X, the CD, so the CI/CD solution that's which I spoke about earlier. It's actually like a modernization tool, and it's kind of like if you've got an existing, it's kind of like a glue command line package that you can install, and it knows how to talk to all the different CI and CD systems. It knows how to talk to Argo, and it knows how to talk to Flux, and it knows how to talk to Spinnaker and Captain, and it knows how to talk to GitLab and Bitbucket and all these things, right? And so let's say you've got a pipeline that's in Jenkins right now. You do not have to migrate every single part of that over to a new system. What you can do is just replace one part of your pipeline with a new system on the side, the new shiny system, and you can use Jenkins X CLI to pass the data, the information. Let's see, it's like the Git repo or the branch name or the stuff, and it will actually allow you to hook and call another system, and it will execute that pipeline. And then when that pipeline is finished, then it will come back to your current pipeline, and you can keep going. And so my point is, using the strangler pattern, you can actually piece by small piece, start to modernize your old pipelines using new tooling without the big bang approach of having to refactor the whole system, right? And so that's Jenkins X is kind of a key to modernizing and stuff. So the innovation of pipelines is what I wanted to talk about, which is actually coming in the future. And I wanted to make you aware of a shift in mindset that's happened in the software vendors of the CD tools and the open source community. Of we're looking back at the past, and yes, we had monoliths, and now we're doing micro, but there's a different architecture that we're taking into the future now, which is pipelines were traditionally webhook based, which means if you push to a branch, I'll take your branch, I'll build that branch, I'll do the whole pipeline, and then it'll pass its test, or I'll deploy, and then you're done. Right, monolithic focus. That's how it used to work, and it hadn't innovated much in 10 years. Now we are literally on the edge. So 2021, 2022, right now is the edge of the reinvention of pipelines as you traditionally thought of them. To a pipeline which is event-driven architecture, rather than say just a kind of big massive blob architecture, and to creating small events. So we're going to move away from the idea of pipelines, and we're transitioning more to the idea of events. So taking your existing pipeline of 10 steps and creating 10 small pipelines, right? And these pipelines are joined together using event-based pipeline architecture. Okay, so we join these together. So just like you would take, so the joining is the pipeline, but you're actually joining many pipelines together, or events, depending on what way you're looking at it. And therefore, pipelines will no longer actually be responsible for actually deploying applications anymore. They'll just trigger events, and it'll be up to another event or another pipeline, or a complete other CI/CD system when we get to the interoperability phase with the event-based stuff. Is that here's examples of event-based architecture, right? To give you an example, so you push to a Docker image, you push it, you build, it passes your test, you're happy with the code, sort of, and you create a Docker image and you push it to a cloud registered like ECR or whatever your Docker hub, wherever you're hosting your image. Now, that will actually trigger an event called something like new image event, right? New user service event has been image has been published, right? So that's an event, and that's that pipeline's, which would a pipeline could be an event. That's that pipeline's job done, right? It triggered an event, and then there's listeners, right? And these other listeners, they're listening for the events to be triggered, so that they can trigger themselves as an event, as a pipeline, right? And then a pipelines produce their own events. So the event will pick this up and run the next part. The next part could be, we're going to run a security scan on your event, which is a very common thing we do these days on Docker images. So that therefore a security scan pipeline will kick in, and then when that's finished, it will have a security scan failed or passed event that will get triggered, and then something else will kick in. And if it's passed, then it will deploy that Docker image through a target environment, which could be publicly accessible. So you wouldn't want to do that before the security scans pass. And then once it's deployed, then that'll be like deploy complete. And then there'll be a listener for that. And it will say like run tests, and then like tests past event. And so you get my point, right? So if you take the way that we used in the software engineering industry in terms of application development, we have events and listeners and, and all that kind of jazz. And so we're taking that lessons learned and that maturity from the software engineering world, and we're bringing it over to the pipeline engineering side of mentality. And then after the tests are complete, or the test results, you can then have an event that's waiting for them, and then it can go and talk to GitHub or something and update your pull request to say your tests have failed or your tests have passed, or you can actually you can give a green tick to a PR to say it's good to go and it gets manageable kind of thing. So this is how things will be structured going forward. So just to reiterate on event-driven architecture, Argo is the leader in this space. So if you like the idea of the granularity of that approach, and you think it coincides quite well with how you want to build the new versions of your pipelines or build new pipelines from scratch, you can then get full usability of event-driven stuff, because Argo has that straight out of the box. And that's why I said Argo's an umbrella, because we have something called Argo workflows, which is what you would consider as typically a pipeline, right? So traditional pipelines, top to bottom, but it's all got all the microservice stuff built in, right, with the GitOps, and it's all brilliant for distributed systems. And if you want to take a look at what's the future of the current state, then that's event-based stuff, and go check out Argo events. And this is my slide on the Jenkins XCLI, which is, if you look at the bottom point, it says there's plugins for Argo, Flux, and all these different providers. So it's kind of like a refactoring tool that you can embed into your current stuff and replace the old stuff with the new stuff. And so that's also how you can make a start today without having to do the big bang refactor. And you can spin up an Argo or a Flux or something on the side, and you can get your stuff running there, and then piece by piece you can modernize your stuff and get rid of the old stuff. And that's me. That's a lot of the content that I wanted to cover with you, and I'm here for questions or chats and points and stuff. How did I do for time? I don't know how long it took. Try to keep it quick.